All right, we are getting ready for the Unit 4 exam. And in number 1, let's just go through and identify all the types of reactions that we see. So letter A looks like a divorce, so that would be decomposition. Letter B here, we've got two things added to one thing, and it looks like nickel is kicking silver out to be by itself. So that would be a single replacement or a single displacement, whatever you want to call it. Next one, oh, I recognize this. Carbons and hydrogens plus oxygen make CO2 and H2O. We know that that is automatically a combustion reaction. Letter D, two things added to two things, and the first two things are swapping places. That would be a double replacement. Might be kind of hard to see because H2O, think of it as HOH. Now it's a little easier to see that the H is moving into K's spot and the K is now with the phosphate. Letter E, one thing kicking hydrogen out. That's another single replacement. Letter F, two things swapping places. H is now with the OH, which is the same as H2O. And PB is now with the SO4, so that's another double replacement. Two single things adding together, that's a marriage combination. And letter H is another divorce, one thing breaking down, so decomposition. All right, now let's look for balancing. So letter A, one Ba on the right of the arrow, one Ba on the left. One carbon on the left, one carbon on the right, two oxygens plus this one on the right. There's three on the right, there's three on the left. So that's already balanced. How about letter B? Let's see, we've got NO3, 2. So we want two NO3s. Now we've got two AGs, so we need a 2 in front of this AG. Nickels are balanced. Letter C, let's use the Cho method. C2, 2C. H6, H6, because 3 times 2 is 6. Now for the O's, we've got 4 O's here, plus another 3 O's. Uh-oh, that makes 7. That means we're going to have to temporarily use a decimal here. So 3.502, and this is a 1. Now we can't leave it like this. We've got to multiply everything by 2. So now out front we're going to have 2, 7, 4, and 6. All right, next one. Let's check it out. We've got K3PO4, okay, HOH. So let's start with the Ks. K3, 3 Ks. Now how many H's do we have total? We've got 3 here, plus another 3. That's 6 H's. So I'm going to need a 3 here. PO4 stays together, so that looks good. 3 O's on the right, 3 O's on the left in this KOH, so now we're balanced. Letter E. Cl3, I always say make odd numbers even, so let's double that. Now I've got 6 Cl's, so we need a 6 here. 6 H's, so we need a 3 in front of the H2. And then 2Al, 2Al. How about letter F? Let's start with the sulfates. SO4, 2, so we need a 2 in front of the SO4. PBs are equal. Okay, so let's take a look at H's. We've got 4 H's here now, and another 4 here. That's 8 H's. So I need a 4 here to make this 8. Now I've got 4 O's besides the ones in the sulfates, and then I've got 4 O's there, so that's it. We're balanced. Letter G, Ag2, so I need a 2 in front of the Ag, and now I've got 1 S on each side, so we're good. Letter H, I see an odd number, O3. Let's make that even. Now, 3 times 2 ALs makes 6, and oops, I meant for this to be a 2. Sorry. Let's go back here. I don't know why I wrote a 3. I was getting sloppy. Sorry about that. Okay, so 2Al2, that's 4Al. And now 2 times 3 makes 6, so we need a 3 in front of the O2 to make that 6. Okay? All right, moving on to number 2. This gets a little harder because we've got to predict the products and write a balanced equation. First one is going to be double displacement because it's 2 things added to 2 things. So now mg is going to be with the PO4. Check charges. Mg is plus 2, PO4 is minus 3. So that's Mg3, PO4 2. Plus, Na is now going to be with SO4. Na is a plus 1, SO4 is a minus 2. So that's Na2, SO4. Now, we are definitely not balanced here. Mg3, so let's try a 3 here. Now that's 3 SO4s, so 3 SO4s. 3 times 2, that's 6 Na, so I need a 2 here to make it 6, and that's 2 PO4s, so we're good. Letter B, easy one. Ag is a metal, so it's trying to kick out Na. Check your activity series, it's not powerful enough to kick it out. Letter C, this is going to be a divorce. So I just write the elements by themselves, and then I check Hofbrinkel. Oxygen's in Hofbrinkel, so it gets a 2. All right, let's make odd numbers even. So 2 times 5 now makes 10, so I can put a 5 in front of the O2 and a 4 in front of the P. Letter D, another single replacement. Lithium's a metal, so it's going to try and kick out the iron. It can. And now Li is with the NO3. So we've got to check charges. Positive 1, negative 1, they do cancel out. Now we had NO3, 3 on the left, so we need a 3 in front of that, and then we need a 3 in front of the Li. Alright, last one, another double displacement. What charge must nickel have if it's with 3, negative 1 bromines? It must have a plus 3. So now nickel is going to be with hydroxide because it moved into barium's spot. So it's going to be NiOH in parentheses 3 plus Ba is now going to be with the Br. So this will be Ba, Br2. Now let's figure out how to balance this here. We've got, let's see, OH3, that's odd, so I'm going to make that even. 2Ni, 2Ni. Now that's 6 bromine, so I need a 3 here to make that 6. 3 bariums, 3 bariums, and now that makes 6 OHs. Oh, letter F, we've got to write out the whole reaction here. Mercury is Hg, and it says it's got a plus 1 charge, and it's with nitrate, which has a minus 1 charge. It says it reacts with iron 3 oxide. So that'll be Fe2O3. And this is going to be a double displacement reaction. 2 things added to 2 things. So now Hg is going to be with O. Again, it's going to be Hg2O since their charges are not canceling out. And Fe, which has a plus 3 charge, iron 3 oxide, is going to be with the NO3. So this becomes FeNO3 3. Now this is not balanced. 3 NO3s, so we need a 3 here. 3 Hg. Uh-oh. We're going to need, let's see, we're going to need more Hgs here. So let's try doing, how about a 3 in front of the HgO, since there's 3 O's here. Now we've got 6 Hg, and then we would need, let's see, Fe2, so we need 2 Fe here, and 2 times that 3, now we've got 6 NO3s. So we're good now. Aluminum reacts with copper 2 chloride. Copper's got a plus 2, chlorine's a minus 1, so that's going to be CuCl2. Is aluminum powerful enough to kick out copper? Yes, it is. And now aluminum is going to be with chlorine. Aluminum's got a +3, chlorine's a -1, so that's going to be AlCl3. Make odd numbers even. We're going to need a 2. That makes 6 chlorines, so we need 3 here to make this 6. Now that's 3 coppers and 2 aluminums. All right. States of matter. So complete the double displacement reactions, balance, and determine the state of matter. So you need your activity series / solubility table here. Na is now going to be with Cl, so charges cancel out. And Ca is now going to be with CO3. Again, the charges cancel out. So check your balancing. I see Na2. Now we're good, 2 Cls. And if I look up NaCl, it says it's aqueous. And CaCO3 is the solid. All right, next one. Pb is a weird one. Sometimes it can have a +2 charge. And it must have a +2 charge here because it's canceling out 2 -1 nitrates. So now Na is going to be with NO3 here. Check the charges, +1, -1. And now Pb with a +2 charge is going to be with iodine. So it'll be PbI2. Nitrates, NO3, are always aqueous. So you can check your chart, but there's going to be aqueous, and the second one's going to be solid. All right, last one here. What charge must zinc have if it's canceling out a sulfate, which is always a -2? Must have a +2. So now Zn is going to be with OH. So check charges, it'll be ZnOH2 plus ammonium, NH4 with a +1 charge, is going to be with sulfate, which has a -2 charge. So we're going to need NH4 2SO4. This one comes out to be aqueous if you check it out on your sheet, and zinc hydroxide is the one that forms the solid. All right, we're getting into some stoichiometry. First, we have to complete and balance the reaction. What charge must silver have if it's canceling out a -1 nitrate? It must have a +1. What charge must copper have if it's canceling out 2 -1 chlorines? It must have a +2 charge. So now Cu is going to be with NO3. So you'll need Cu, NO3 in parentheses 2. And Ag is going to be with Cl. So this is not balanced. We're going to need a 2 in front of the AgNO3 and then a 2 in front of the AgCl. What type of reaction? That is a double replacement. Now, it says how many moles of CuCl2 would be required to fully react with 248 grams of AgNO3. Always start by writing what you know and drawing a line underneath it. Then, whatever the units are, you copy those down again. Grams of AgNO3. We're trying to get from grams of A to moles of CuCl2. That's our B. So first step, we're going to have to divide by the molar mass so that we can use that mole-to-mole ratio. So I've got to go to my periodic table and look up how much each of these weighs. And there's 3 oxygens, so 3 times oxygen's weight. This comes out to be 169.91. We're not done yet. For every blank moles of AgNO3, how many moles of CuCl2 are even needed? Let's go back to our balanced equation. For every 2 moles of AgNO3, you need only 1 mole of copper chloride. So if you think about what's happening here, you could do 248 divided by 169 and stop there. I can't do that in my head, but it's over 1. Let's say 1.5 or something. You only need half that many moles of the other reactant. So now we're going to multiply across the top, divide by the bottom, and we're going to get our answer. So 248 times 1 divided by parentheses around the bottom when you multiply, and you should get 0.73 moles of CuCl2. Okay, number 5, another reaction. What must have happened here? Lithium must have kicked calcium out. And this is not balanced. You end up needing a 3, a 2, and a 6. This is a single replacement reaction. You're starting with 112 grams of Ca3PO42, and you want to know how many moles of Li3PO4 would be produced. Same thing, start by writing what you know. You're going to divide by the molar mass of Ca3PO42. So that's kind of a long one to add up. It comes out to be 310.18. Okay, then grams are going to cancel out. Then you want to know, using your balanced equation, for every 1 mole of Ca3PO42, you're going to produce 2 moles of Li3PO4. Multiply across the top, divide by the bottom, you end up getting 0.72 moles of Li3PO4. What would the percent yield be, it says, if you actually got 80 grams? Well, we don't know the theoretical yields yet. So 0.72 moles of Li3PO4 multiplied by its molar mass will tell us what the theoretical yield is in grams. So multiply by 115.79 grams of Li3PO4, and that comes out to be 83.37 grams of Li3PO4. So you did pretty good. If you actually got 80 grams divided by your theoretical yield of 83.37 times 100, you got about a 95% yield. Okay? All right, next one. First you had to balance it, so it comes out to be 3, 2, 1, 6. Right? What you know, 7 grams of potassium nitrate. That's how much you want to make. You want to know how many grams of potassium phosphate are needed. So first step, divide by the molar mass of KNO3 using your periodic table. And then we need the mole to mole ratio. For every 6 moles of KNO3, I'm getting that from the balanced equation, you only need 2 moles of K3PO4. Last step, let's get moles of K3PO4 into grams. The molar mass of K3PO4 is about 212.27 grams. Multiply across the top, divide by the bottom, I got 4.9 grams of K3PO4. New question. You mix 20 grams of zinc nitrate with potassium phosphate and purify and dry the precipitate. And then you actually made 7.62 grams. What's your percent yield? So first we got to do the stoichiometry. 20 grams of zinc nitrate. Divide by the molar mass. It's 189.41 grams of zinc nitrate is equal to 1 mole. So you don't even have a mole because you only have 20 grams. Okay. For every, use the balanced equation, 3 moles of ZnNO32, you need 2 moles of K3PO4. So let's figure out what that's going to be in grams. 1 mole of K3PO4 weighs 386. Oh, wait a second. You discover you've made the precipitate. Sorry, I read this wrong. We got to go back. Going too fast. Oops, let me erase this. See, that's a good thing I caught that. Sometimes you do that. The precipitate is what it's asking for. That's zinc phosphate because that's the solid. Precipitate means solid. So for every 3 moles of zinc nitrate, you make 1 mole of ZN3PO42. That thing is a beast to add up. 1 mole ZN3PO42. I added it up to be 386.11 grams of ZN3PO42. Can barely fit this one. Multiply across the top, divide by the bottom. I got 13.6 grams of ZN3PO4 That's how much you're supposed to make. I need a little more space here. Yep, stop inking for a second. Ooh, sorry, it's getting all messed up. All right, so you only made 7.62 grams. That's your actual yield, divided by you were supposed to make 13.6 grams. So you get a 56% yield. All right, last one. Write the balanced equation. Solid aluminum and oxygen gas combine to form solid aluminum oxide. Aluminum oxide, we got to crisscross charges. Al2O3. This is not balanced. Make odd numbers even. 4, 3, 2 out front. You've got 20 grams of aluminum, and you're assuming a bunch of oxygen gas. How much aluminum oxide will you make? So divide by the molar mass of aluminum. For every 4 moles of aluminum, you make 2 moles of aluminum oxide. 1 mole of aluminum oxide weighs 101.96 grams. Multiply across the top, divide by the bottom, 37.8 grams of aluminum oxide. So it kind of ended on an easy one. All right, good luck.